Okay, so today we're going to be graphing systems of inequalities. This should actually say inequalities and not equations, if you want to make that change on there. So we're going to solve systems of inequalities by graphing, and then we're going to write systems of inequalities by looking at a graph. Equation has to have an equal sign, so that's why it shouldn't say equations, it should just say inequalities. Okay, so prior to now, we were doing two variable inequalities and we were graphing just one line. When we're graphing systems, we're going to graph two lines. And the only way we really do inequalities is by graphing. So we're not going to do substitution and elimination and all of that when we're working with inequalities. So the first thing we want to check for is to make sure both equations are in slope-intercept form. So the first one is already solved for y. We have y is less than 2x minus 3. But the second one, we have to solve for y. So if I solve that for y, Carly, what would it say?
Y.
Mm-hmm. Plus 2. Good. So we're going to graph the first equation, and then we change the second equation to make it easier to graph. Emily, tell me how I would graph that first equation. What do I do?
Put a dot at -3, dot to the 1.
Okay. Put a dot at -3. Now we're going to go up 2 over 1, up 2 over 1. You only need 2 points to determine a line, but if you draw 3, you have a better chance of getting a straighter line. Emily, what kind of line am I going to do? Solid or dashed?
Dash.
Mm-hmm. And where am I going to shade?
Below.
Below. Okay, so I'm going to do the same kind of shading I did before. I'm just going to use vertical lines. And it's really important that you take up the whole coordinate system. You don't want to just draw a little half line and kind of roughly shade under it. You want to really take up the whole space so that we're looking to see where graphs overlap, and you wouldn't be able to see that if you did not. Okay, I'm going to change colors for the next one. Let's see. Reagan, tell me how I would graph the next line.
You would go up 2 and make it cross.
Okay.
And then up 1 again.
We're looking at this equation.
Oh, well, okay. Down 2 over 1.
Good, down 2 over 1. So down 2 over 1, and I'll do another point, down 2 over 1. And should I draw a dashed or solid line?
Dash.
Good. Well, on the video of this, you won't be able to see that I'm using a ruler, so it'll just look like I'm drawing really straight lines.
Now I know your secret.
Yeah, I shouldn't. Okay, now where do I shade, Reagan? Above it. Now, since I shaded up and down this way, one trick to help you see the overlap is to go horizontally for this one.
Smart.
So this makes it, plus the fact that I use 2 colors, and when you're working in class, you can use colored pencils if you want, or you can use colored pencils if you have them at home. So the area where it overlaps is the solution set. So remember, for inequalities, we don't just have one solution, we have lots of different solutions. Let me just highlight this. Ooh, isn't that pretty? Never used the highlighter before.
Hey, my.
So that's our solution set. So let's name what some possible solutions would be. Actually, let me ask you some. What about the point, whoops, hang on. I don't want that. No. Back to my pen. Okay, what about the point 3, 1? Is that a solution to that inequality?
Yes.
Yes,
Yeah.
it is, because 3, 1 would be right here, and that's in our doubly shaded region. What about 0, 1?
No,
Why not?
it's not in the doubly shaded.
Right, it's not in any shaded, so that would not be.
No.
How about
5, -3.
2, 2? Would that be one?
Yeah.
Well,
Wasn't- isn't it like
let's
right
take a
on the
look at
line?
that one.
Wait, no.
2, 2 would be
Yeah.
1, 2, 1, 2. It's in part of the shaded region, but
Oh.
it's not in the overlapping shaded, so
Nope.
2, 2 is not. How
Nope.
about 1, -3? Is that a solution?
Yes. No.
No.
No,
No.
it's not. Okay, last one, 4, 2. Is that a solution?
No.
Yes.
No.
Yep, 4,
Uh-huh.
2 would be right in here.
No.
So yes, that would be a solution. Okay, next one is one for you to try, so I want you to take a minute. We're gonna pause this. If you are listening at home,
Yeah.
you should pause this
Bye.
as well. Okay, so what's the first thing that we have to do to get started? Noah? Good, we need to get rid of that -3x. Okay, so we get y is less than or equal to what? Good, 3x minus 4. Okay, now let's graph our equations. Haley, tell me how to graph the first one.
Like this or
This first one.
oh, okay, so you go to -5. I'm positive.
Positive 5, good.
And go down on
Good. Then 1 over 1. Another one. Okay, am I going to use a solid or a dashed line? Good. Those are so much easier to draw. And make sure you take up the whole coordinate graph. And am I going to shade above or below? Above. So I'll do vertical. Okay, now let's do the other equation. Stephanie, tell me how to graph the next one. Okay,
and then
good. Up 3 over 1, and we'll do one more. 3 over 1. Okay, solid or dashed?
What if you don't have a yardstick?
Nice.
You use a ruler.
What if you don't have a roller?
Then you have to eyeball it.
Use your
That's it.
forearm.
Okay, where am I
straight
gonna
down.
shade this one, Stephanie? Under. And under is on the right-hand side, it's not on the left-hand side, right. Okay, so I'm gonna go under. And I'm gonna use horizontal.
Oh, how are you doing that so speedy?
That's pretty good, huh? So you can clearly see where the overlap is. Let's just highlight that a little bit. There we go. Okay, now, give me an example of a point that would be a solution to this system. Kiara?
Oh.
3, 3, let's see, we'd have 1, 2, 3, up 3, that would be
Girl.
right about here. So yes, 3, 3 is a point. Jackie?
4, 4.
4, 4. Let's see, we have 4 here, 4 up here, 4, 4 would be a point. One more, Cameron?
4, 3.
4, 3. Let's see, 4, 3 would be right here.
Cameron.
So 4, 3 could be a point. Okay, good job. Does that make sense to everyone?
Yeah.
Yep, yep.
You
Okay,
dead.
let's look at the next slide. This one, we're gonna go backwards. So we're gonna start with a graph, and we're gonna write a system of inequalities. So it asks which system of inequalities is represented by the graph below. And the steps that I gave you are, first, write an equation for each line in slope-intercept form, and then decide what inequality symbol to use based on solid dashed line and shading. You can actually start with step 2, and I think I'm actually gonna do that. I'm gonna start with step 2. So I'm going to decide right away which inequality sign to use. I'm going to use a red pen, and I'm going to start with the red line. So I know I have y something. Is my red line like looking at where it's shaded, what inequality symbol would I use? Jackie, am I gonna have an equals in my inequality?
You're gonna have, you're gonna have less than.
Good.
Without, well, less than not equal to.
Right, no equals, because the line is dashed, so I'm not gonna have an equals, and it's shaded
for the
underneath,
red
so it
one.
needs to be less than. Yes, this is for the red one. Okay, now we just go and write the equation for the line, just like we normally do from slope-intercept form. So, Cameron, what's the slope of that line?
What line?
The red line. No, the 5 is the y-intercept. 5 is where it crosses the y-axis, but what's the slope? No, Kyle?
Down 1/2.
It goes down 1/2. So if we looked at a point, say here,
Up 1.
and then we looked at the next point, to get from this point to this point, we go down 1/2. So the slope is -1/2. That's in front of x. And then Cameron, you already told us the y-intercept, so how would I finish this equation? What's your y-intercept? 5, so plus or minus 5? Plus 5. Okay, that's your first equation. Now let's do the blue line. Anthony, what inequality am I going to use? First of all, am I going to have an equals in my inequality?
Yes.
Yes, I am. Okay, now, is it shaded above or below the blue line?
What do you mean?
Here's the blue
Above.
line. Where's the shading for the blue line? Is it above or below?
Whoa. No, above.
Above. It is above. It's over here. You can see some blue by itself and then where the blue and the yellow combine. So what inequality am I going to use? Is it
What?
greater than or less than if it's above?
Greater than.
Greater than. So I want greater than or equal to. Okay, now, Kyle, what's my slope?
2.
2?
Go on.
Okay, so if we go from this point, you're saying we go up 2? That doesn't work. Over 1 would get us here. 2 over 2, which is actually 1. So our slope is just 1, and we could look at the second point. It goes up 1 over 1. So our slope is just 1, so we can just write x. What's our y-intercept, Carly? -1. Good. So it's x minus 1.
Oh.
So that's our system. Okay, now, I don't think your page, does your page have assignment listed here?
Back.
Yeah, it shouldn't either. I had deleted it and now it's back. So anyhow, we have another example to look at. I want you to try the next example on the next slide. We're gonna pause this for a minute and then we'll come back and talk about it. Okay, let's write the system of inequalities for this graph. Let's start with the red line. Carly, can you tell me what the equation is for the red line?
Y.
Oh, wait a second. That was a disaster, okay. Y. Oh, that's not red. Y less than
+1/2 x.
Okay, now looking at this red line, could I ski down this line or would I have to walk up it?
Ski down.
Go down, so what does that mean about your slope? It should be a negative slope. Because to get from this point to this point, we'd have to go down 1 over 2, so it would be -1/2. Other than that, good. Everything else is good for that one. Okay, now for the blue line, let's see. All right, go ahead, Jackie.
Okay, I have y
Uh-huh.
is less than -1/2 plus 1.
Wait, that's the red line. You just gave me the red line equation again.
Down 1 over.
You need the blue line equation, the other equation. This one.
Y equals less than or equal to
Okay.
1/2
1/2 what? Just 1/2?
X
X, thank you,
plus 1.
plus 1. Good.
Oh,
That's
sorry.
what the system should look like. Okay, now, part B asks us, in part A, so the system that we just wrote, is the point where the boundary lines intersect a solution of the system? So, choose a different color. This point right here, would that be a solution to that system? What do you think?
No, like where the.
Right there, this point where the two lines intersect, could that be a solution to the system? Right, you're
No.
shaking your head no, why not?
Because it's not in the shaded part. I don't think.
Okay, but why? How do we know that it's not in the shaded part? Because it's on the boundary line, right?
I don't know, because it's only halfway.
Sometimes we include the boundary line and sometimes we don't. How do we decide whether we include points on the boundary line? or not?
Because one's going up and one's going down. So I don't see that.
No? Noah? Not quite.
Perpendicular.
No? Has nothing to do with any of the angles of the line. Think about when we were looking at lines before, sometimes we included points on the line as part of the solution and sometimes we didn't. How do we know? If there was just one line, how do we know whether to include the points on the line or not?
You're
It has to do
confusing
with
me.
the inequality symbol.
Oh.
Think about the whole dashed solid thing.
One's dashed and one's not.
And what does that mean if it's
It
dashed
can't be the
and
same
solid?
thing, it can't be both.
Right, but what does it
One
mean?
can't be equal to that number.
Right, which one can't
The-
be equal?
The dashed one.
The dashed one, good. The dashed one, we don't count the points on the line. So this point where it intersects would be a solution to the blue line, but it would not be a solution to the red line because the red line is dashed. Okay, so the answer to part B is no, because the red line is dashed. Okay, any questions?